Let's go to Gabriel.
Hello, Stefan. Can you hear me?
I can hear you just fine.
Good.
Let me
Good.
introduce you, and we should say that actually, as far as influencers is concerned, you're about 10,000 ahead of me. So I
I'm
hang
not
my
counting
head, I
numbers.
hang my head in shame, but you've been at it a little bit longer than I have. So here goes Gabriel Fairman, well-known entity in the industry, CEO of Bureau Works. He's someone who truly embodies the spirit of entrepreneurial grit and innovation. Gabriel is the founder and CEO of Bureau Works, a company he started with a single translation typed on a word processor and grew into a full-scale TMS powering content for global brands like Coca-Cola, Harley-Davidson, and Zendesk. In his session, Gabriel will share groundbreaking insights from his hands-on experimentation with full text translation using generative AI. That's certainly a hot topic and a major innovation in the TMS space. Take it away, Gabriel. I've done enough talking.
Thanks so much, Stefan. I mean, that's very kind words. And I want to also thank Ben and Marina for great presentations. Was learning a lot from them as well. Let me see if I can go into full screen here and share my screen. Here we go. Can everybody see my screen? Perfect. Good. All right. So findings and theories in a push for a fully vectorized translation environment. Hopefully, by the end of my talk today, we'll understand what a fully vectorized translation environment is, what it means, and what we're trying to do. Don't worry about understanding this right now, because that's what we'll unpack today. So first, let's kind of take it a step back and talk about what's wrong with segments. So segments are great. That's how we built all of this localization infrastructure. And they come from this idea that at some point we had to do, we had to, in order to make translation memories feasible, we needed to create a way to correlate sentences to previously translated sentences. And the way we could do that was by parsing and segmenting them into little boxes. So if you think about it from a more abstract perspective, the nature of segments was, okay, I have like a spreadsheet or a database, but basically a spreadsheet for past translations. And now I have another spreadsheet for something I'm working on. And the fact that I have these individual cells or these individual entries allowed me to be able to search, right? So you needed segments in order to search for relevant matches. You needed segments to be able to perform little bite-sized operations that were compatible with the computing power and possibilities that we had 30, 40 years ago. So segments, super important, super powerful, but we we built the entire industry around something that doesn't necessarily extract the most out of AI, right? So they're built for syntax-driven operations. And so when we look at AI and try to apply it in segments, it's a massive retrofit. We've done it, lots of other companies have done it as well, but it really is like running a fire hose through kitchen pipes. That's the best way I can kind of think about it. You know, when you think about the massiveness of what a large language model looks like, and you compare it to this tiny little amount of information contained in a segment, you can't do that much. And sure, you have workarounds of, you know, you can consider the segments below and the segments above. You can consider a bunch of segments at the same time, but you're still boxing information in. And when people talk about this whole idea of translation becoming closer to content creation, that makes a lot of sense, but you need tools to be able to make that happen, right? So just to exemplify what I was talking about, when we talk about like a traditional relational database, you have these sentences. So maybe you have, for instance, in a translation memory, for instance. So maybe you have the sentence, John has gone to the store, and you also have the sentence, John went to the supermarket. And even though these sentences from a propositional perspective, even though they say pretty much the same thing, right? Has and went are both verbs for having done something in the past, gone somewhere in the past, went and gone, very similar actions, store and supermarket, kind of similar kinds of places. From a syntactical search, you wouldn't find a match between these sentences. If you think about, Levenstein edit distance and how typical searches and translation memories are done, you're not just the difference in characters are just too big. So you're not going to find the similarity, even though the sentences are pretty much saying the same thing. Now, in a vector database, you're comparing things in a very different way because you're vectorizing the information. So John is a vector, has gone is another vector, store is a vector, all these different words, all these different tokens, whatever, if you want to use the AI terminology, but all these different words, they're vectors. And because they're vectors, they can be stored in an unstructured kind of way. So we're not just storing, for instance, English target, we're storing stuff. And it could be stuff like different languages, it could be images, it could be sounds, it could be anything that can be vectorized can be stored within this framework. And that opens the stage for a very different kind of conversation. And this is kind of like the conundrum that I feel that we're in is that, the industry still needs all of the benefits that the segments brought to the table. So we still need glossaries, we need precise knowledge leveraging, we need QA checks, but we also need to extract the maximum value from AI. And in that end, segments are great, but they're also a prison because of all of these things I mentioned. And another thing, segments create very strict source to target correspondences. Sure, you can maybe add segments or remove segments, but the correspondence is fairly strict. And when we're moving into content creation, you can't work with that level of strictness. You need more leeway to add or remove content as necessary to change, adapt, etc. So let's just get a little bit more detailed about what a vector is, right? So I like this definition. The vector is basically a numeric fingerprint that represents the meaning of something, like a sentence or image, so that a computer can compare it to others, right? So in this context, a vector is just a list of numbers, like with this example here, 0.12 minus 0.98. These have different dimensions, but think about it as a point in a 3D in a 3D cube where things are lying. And what's interesting about vectors is that they allow us to compare very things that are typically not comparable. Like from a syntactical perspective, camel and dog, there's no correlation between them, or camel and whale. But in a vector database, we can begin to establish certain correlations. After all, they're all living beings, and that correlation can be established. And one is an aquatic living being, and another one is a terrestrial. Two of them are terrestrials, and all of them are mammals, etc. So you can establish these correlations, and you know that the chair is a little bit further away, etc. So you can spatially place things, concepts, right? And that allows this spatial placing allows us to find much deeper correlations between different things, information, right? And so when we look at how this works in the environment that we're working on and in our research, we're looking at first, there's a storing process, right? So you need to get the information into embeddings and then store those embeddings in a vector database. Again, the embeddings are the numerical descriptions of the vectors, right? So they're basically you go from information into embeddings, and those embeddings are stored in this vector database. I like to think about it as like this very spatial way of placing information around. So now instead of information being stored in this very one-to-one correspondence, you're basically storing stuff in space, right? So it's much more fluid, much more dynamic, also harder to interpret, harder to understand. Then the next step comes into the retrieving process. So if you run the query, for instance, the bull by Pablo Picasso, you're also transforming that query into embeddings. Again, you have the vector representation of those embeddings. And then comes the concept of nearest neighbor, right? So in a space in a vector search, you're not searching for that exact segment or for that exact piece of information. You're looking for the closest vector to that embedding that you're looking for. So that's the concept of the nearest neighbor, and that's the results that someone would see. So when when we're looking at vector-based architecture outside the LLM, which is again, that's the big shift, right? Because LLMs by design, they're vector based, they're all token driven, etc. But we're creating an environment where even when you're not inside the LLM, you're still working in this vector based architecture, and that allows us to create much deeper correlations between different things within that environment, and it also allows us to also create and preserve terminological precision, right? The other thing that this allows, which is super cool, is this creates an environment that's truly cross-functional. So let's say, for instance, if you want to go from something that's an audio into a video, or from a video into a tweet, from a tweet into an email, that allows that cross-functional creation interface because that's natural to a vector-based environment. Because again, think about the information is very fluid, it's not static, right? So perhaps this is the most important component, is that now there's no need for source to target strictness. You can start from the target because, again, the key transformation here is that it doesn't have to be a linear process anymore. And so to exemplify this, if you're working on a translation and let's say the machine translation or the AI translation is good enough, you can iterate on that. And the vector-based environment will ensure that you're aware of when and how you're deviating from the source without necessarily having to go segment by segment. Everything is interrelated. So let's say in a segment translation, let's say something you reach segment 79 and all of a sudden you realize that you made a change in tone or you made a change in terminology that will impact segments 1 through 78 as an example. In that example, you would have to either go back to segment one and reapply those changes, or you would have to have some kind of script or some kind of macro that would do that for you. But in any event, you're going down a sequence of segments, and then to make a change, you would have to go back up. In this scenario, if you make a change in segment 78 that impacts all of the rest, because the segments are not ordered, because it's just information, it's allowing information to change information. And that's, in my opinion, that's the nature of language, right? The nature of language is you have characters that are related to words, words that are related to sentences, sentences to paragraphs, paragraphs to pages, pages to text. And you basically have text that is producing meaning. So let's say if you think about a book, right? And at the very end of the book, you find out this massive reveal where the character that you thought was the protagonist is actually a fraud or is actually a spy, is actually something else. That will change the nature of all the information that you saw before that. Because we process information in a dynamic way, it's not like we have to necessarily reread the book to make sense of it. But if you were working segment by segment, you would have to do that. So it's a very different way of approaching information, and it frees us up from a linear driven approach to translating. And it really opens up the door to freedom. And I know that I talked about a bunch of abstract concepts and would love to hear if anybody has any questions.
Fascinating, Gabriel. Very, very cool. We have lots of questions, so let's dive right in. First question from Michelle Fari. I hope I'm saying that correctly. When you vectorize a TM in BureauWorks, how many dimensions does the vector have? And is a fuzzy match in BureauWorks based on these embeddings?
So in BureauWorks, we have well, the production environment is still based in segments. What we're working on is what we call the free flow editor, which will be live in July. The free flow editor is based on purely vector search and purely vector translation experience. As far as the translation memories go, they're just added as context. So the number of dimensions that every TM have will be a function of the necessary transformation applied to those embeddings. So it's not something fixed. It's not something that we're predetermining. It's something that will vary according to the information type, the number of dimensions that we need to record that embedding. So, and as far as the search goes, it's you don't need to have a one-to-one correlation. You can have you can have more dimensions in the search, for instance, itself than in the embeddings that are actually stored. So you don't have to have a one-to-one correspondence in dimensions.
Awesome. Next question from Eva Martinez Garcia. How this vector representation works in a multilingual scenario? Can we then perform Reina dash woman plus man? I'm not sure how to represent. I need an LLM to represent the question. Or ask for some fact in Spanish to retrieve an answer stored in our database in English. Does that make any sense?
Yes, absolutely.
Yeah,
It's completely language agnostic. So
yeah.
instead of again, in typically TMs and other kinds of information, they're going to be stored by language. For instance, in this case, it's all the information is stored together. It's the embeddings that will have, let's say, the labels for the specific languages. And because you're interacting always at the embedding level, you can have very complex operations. For instance, asking a question in Spanish but requesting a response in English, or searching for something that's an image but requesting a response that's in text.
All right. Next question is something I actually wrote an article about recently, but I'm going to watch for your answer on this. Is this vector approach similar to knowledge graph? What's the difference between knowledge graphs and vectorization, Gabriel?
Well, I'm not an expert in knowledge graphs, so I won't be able to answer that. I think for me, what's important is the result that we're looking for. So, when we think about AI, we're really trying to value, at least this is my opinion about AI. It's it's a really great tool. And but I also really value the human spirit, the human authorship. And I think, at least for me, it's been changing the way I feel about my own writing. So, for instance, I'm beginning to treasure my own spelling mistakes. I'm beginning to treasure all the little ways in which I am deviating or different from AI. That's what makes me special. It doesn't matter if it's a mistake or not. I want to figure out what is special about me. And the vector-based environment is a lot more conducive towards that because I'm not boxed in. If you put me to translate with segments, I'm a lot more likely to be very similar to the machine because I mean, you're basically forcing me, the human, to think like a machine when you're putting me in segments. If I'm working in a space that's free, now I have a lot more authorship, I have a lot more creativity. And I think this is just my personal opinion, Stefan, but I think in the years to come, one of the most scarce forms of content is going to be authentically generated content. And when I say authentically generated, it doesn't mean that it has to be 100% from a human. It needs to have the right level of intervention that shows that there's authorship. So I think this question of authorship is going to be huge because I think people are going to get sick and tired of reading stuff that is feeling like AI generated or AI driven. And I think you need the right tools and the right environments to make that work. And in my opinion, at least, I don't think the segment-based approach will be conducive for that because, again, the segment-based approach is all about efficiency, it's all about volumes, it's all about scaling, and it's amazing for all of that. And I'm not even sure that, for instance, it will be possible to translate, let's say, software localization using a vector-based approach because I'm not sure if it's going to be compatible or not. But I am sure that we're looking for a way to make sure that human expression is still something very valuable and at the same time compatible with the expectations for value and scalability that people have due to AI.
Yeah, we have time for one more, just 2 minutes. You'll forgive me for being selective and just picking one that I think ties in very nicely with what we've been talking about. If you don't break the text in segments because you want the model to have the whole document as input, what does that mean for post editors?
So it's actually very flexible. You can decide if you want to work with an entire document, if you want to work with chunks of the document at a time. So the idea is you're making it entirely flexible as far as the context window that you're working with at any given moment. As far as what it means for the post editor, one of the things that we're working on is being able to be a lot more smart about what the post editor is doing. So, for instance, really being able to log not just the changes that are being made by the editor, but understand the nature of those changes and then use the nature of those changes in future suggestions as they move along, as well as allow them to rethink past decisions that were being made. Because again, I think maybe that's the big shift from a post editing perspective, right? It was typically everything was pre-translated, and then you would make changes here and there. We went into what I believe was an evolution of that, because now in our context sensitive application in segments, at least the segments are learning as you move linearly through the document. In this case, we're working on a different kind of paradigm where the entire document itself could be shifting based on different changes that are made by a post editor. For instance, maybe they're making something in paragraph number 3 become more formal, less conversational, more authoritative. Maybe that's going to lead them to rethink something that they wrote in paragraph 2 or paragraph 1, for instance. So it's going to be an entirely different experience entirely, and it's more geared towards, I would say, post authoring as opposed to post editing. I would say it's a
Yeah.
subtle shift, but it changes a lot. I think it's more
Are
about
you
going.
feeding in? Are you feeding in those changes back to the LLM to teach it to improve the outputs
Oh
going
yeah, yeah,
forward?
everything is entirely fluid and dynamic because everything is taking place through embeddings. That communication is very seamless. So we're not going into, we're not going to text into embeddings, then back to text, then back to embeddings, because that's typically, if you're working in these complex operations with LLMs, you're having a lot of translations back and forth from text to embedding, from embedding to text, etc. In this scenario, you're basically working at an embedding level within the editor and within the LLM, which really enhances efficiencies of operations and those exchanges that you're talking about.
Awesome. Well, I'm going to get kicked in the butt if I don't wrap it up here.